Hello student, I am Dr. Namika Goel from ABES Engineering College, Ghaziabad. Today I am going to discuss some important questions of Unit 5 of the subject Design and Analysis of Algorithm. These are the some important questions which repeatedly asked from the AKTU examination. So let's discuss one by one in detail. Your first question is explain and write the name string matching algorithm. Suppose the given pattern P equals to A, and B and the text string A, C, A, B, C. We already explained string matching algorithm in detail. So according to that question, first you have to write string matching algorithm step by step, and after that you just take an example which already given here we given text string A, C, A, B, C, and in this given string you have to find a pattern AAB into that string. We know that in naive string matching algorithm we just try to find out our pattern one by one. We just match our character of pattern into a given text string one by one. Where we find a match, we just return the values. Value will return the first occurrence of that particular string. Like here you can see that our pattern PAAB will occur in a given text string at second position, right? So we just return our output where shift value 2. We just find our pattern into a given text string. Our next question number 2, 3 and 4, these three questions based our next algorithm, that is KMP, North Maris Pratt string matching algorithm. So these are the variations of North Maris Pratt questions. According to that question number 2, write KMP algorithm for string matching. So here first you write the KMP string matching algorithm one by one, and after that perform the KMP algorithm to search the occurrence of a pattern ABAAB in the text string ABBA, BAA, BAB. So in this question, you just try to try then your string PMP string matching algorithm according to that given numerical. So in this in KMP algorithm, first we'll compute the pi table of a pattern ABAAB. We just compute the pi table on the basis of their occurrence of each character. Like if I want to, so let us take an example. Suppose I want to compute the pi table of a pattern A, B. So we just first do the indexing of this pattern 1, 2, 3, 4, 5. So how we can compute pi table? The occurrence of A is first time. So it will be 0. Occurrence of B again first time. It will be 0. Now occurrence of A will second time. So what we have to do? We just try to copy our previous index value, that is 1. So here we just write 1. Again A will occur repeatedly. So again we copy our first occurrence of A, that is 1, and then B, the occurrence of B is again repeated and the occurrence of B is 2. So the pi table is 0, 0, 1, 0, 0, 1, 2. So in KMP algorithm, first we compute pi table just like that, and after that what we have to do, we just try to find our pattern into a given text string one by one, match each character. If our character match, so we just return the shift value, or we can say the position where our pattern first occur in the given text string, or otherwise if mismatch occur, so we just backtrack our pattern at the position of the last character match into our pi tables, right? So this is KMP string matching algorithm. So in KMP algorithm, maybe you have it may be कि आपसे क्वेश्चन के साथ पूरा का पूरा स्ट्रिंग मैच करने के लिए पूछा जाए, जस्ट लाइक क्वेश्चन नंबर 2, or it may be possible in question number 3, discuss KMP string matching algorithm and also find the prefix function for the following pattern. In that question you just find out the prefix function of a pattern, not to match, or you can say not to find a pattern into a given text string. Similarly in question 4, just giving you a pattern, and you just have to calculate the pi value. You can see the prefix function of Knuth-Marisper string matching algorithm. Our next question, that is write Rabin-Karp string matching algorithm working modulo Q is equals to 11, and how many spurious hits does the Rabin-Karp string matching in the text when looking for the pattern P equals to 26, right? So in my wrapping cup string matching algorithm lecture series, we already explained this example in details. So here what we have to do, first we'll write the wrapping cup string matching algorithm, and after that what we have to do, we just find out the hash function using p mod q. Here p is equals to 26, 26 mod q, that is our hash value. So first we'll try to match our hash value to a given text string. If our hash value is matched, after that we analyze the pattern. If our pattern match, so we can say it's a valid hit. If our hash value match to a text string but our pattern is not matched, so we can say that is a spurious hit. So in that question we just count the spurious hits and return the value of spurious hits. We already discussed this question. So these are the some important question which is based on string matching algorithm. Suppose you all understand. Next, question number 6. Question number 6 and 7 based on our NP completeness theory. So according to that, define NP hard and NP complete problem. What are the steps involved in proving a problem NP complete? Specify the problem already proved to NP complete. So in this question, first you all explain what is NP hard problem and what is NP complete problem. After explaining NP hard and NP complete problem, you just take an example, any example, because here not mention any specific example. So in that case, you can take any one example like traveling salesperson problem, 01 knapsack problem, and with the help of these problem, you can prove that we can transfer or we can convert our NP hard problem to NP complete problem. NP hard and NP complete, there is a one major difference between NP hard and NP complete problem. In NP hard problem, we can use non-deterministic algorithm, and these algorithm will take exponential time for the computation. If I am able to convert our non-deterministic algorithm and solve and try to solve the solution in polynomial time, so these problems are called NP complete problem, right? So in question number 6, and similarly in question number 7, you just explain what is PNP problem, then NP problem, then NP complete problem. Here mention that here you just prove the traveling salesman problem is an NP complete problem or not. So here you can explain traveling salesperson problem in detail. After that, question number 8, which is based on the concept of approximation algorithm. Similarly, question 9. In question number 8 and question number 9, first you have to explain approximate, what is the concept of approximation algorithm. And after that, with the help of vertex cover problem, algorithm, with the help of approximation algorithm, we just try to explain vertex cover problem. Here we can also use a term Pn. What is Pn? Pn is nothing but it is an approximate ratio. What is the value of Pn here? Pn is nothing but it is the ratio of, it is a ratio of cost of exact solution and cost of optimal solution. So with the help of vertex cover problem, you can explain both approximation algorithm or approximate ratio in detail. We already discussed these topic in my lecture series. Next questions based on the fast Fourier transform, right? So it may be that you can that in your examination the question is write a short note about fast Fourier transform. It may be possible that just like question number 10 and 11, that they can ask the applications of fast Fourier transform. What is the application of fast Fourier transform, and also write the recursive algorithm for fast Fourier transform, which already discussed in our lecture series. Or here you can see fast Fourier transform, application of fast Fourier transform. So in question number 10 and 11, you just explain the recursive algorithm of fast Fourier transform and why we require or why we need fast Fourier transform. After that, the last question, which is based on randomized algorithm. In randomized algorithm, generally they ask the short note. So here you just explain randomized algorithm concept with the help of randomized quicksort. So these are the some basic or some important questions which repeatedly ask for AKTU examination. I hope You understand? Thank you.